So now we're starting section 7.3, which is about ellipses, and these are our oval shapes. So an ellipse is defined as the collection of all points in the plane, the sum of whose distances from two fixed points, which we call the foci, is a constant. Foci is just the plural of focus. And then V1 and V2 are the vertices. So if you think about like an egg, V1 is the largest point, the furthest away point from the center on the oblong side, and the other vertex is at the other end of the egg. So through the long ways. The major axis is the axis of the ellipse that goes through the vertices and the foci, and the minor axis is perpendicular to that. So if you remember with our circle, we had a string and we fixed one point, and that was the center of our circle, and we attached a pencil to the other end of the string, and that pencil drew our circle. The ellipse is similar. We still have a piece of string, but this time we fix it at both ends. And those fixed points are the foci. So I'm highlighting our piece of string here in blue. And the trick here is that the distance from one focus to any point and the distance from the second focus to that same point, if we add those two distances together, they always equal a constant. That constant can change, but no matter where we are on the ellipse, that is still true. The two distances never, if we add them together, never change. So you can see the string has to have a little play. Now I have a simulation online that will show us the same thing, so hopefully it will give you a better idea of what happens. And here is what it does. So you can see we've got our two foci here, and I can change the length of our string. So right now, my string is 27.68, but my foci are not that far apart. If I hit draw, it will show you how this works. So you can see that no matter what happens, that distance, when I add those two distances together, doesn't change. It stays at that constant 27.68, which is the total length of the string I had. Okay, so hopefully that makes a little sense. So let's talk about these ellipses. So we're only going to worry about ellipses whose center is at the origin. So our first ellipse has the major axis is on the x-axis. And its equation looks like x squared over a squared plus y squared over b squared equals 1. Now here, a always has to be bigger than b, and both of them are positive. And to figure out b squared equals a squared minus c squared. So if you're wondering how that works out, the vertices are at negative a0 and positive a0. So the a A is what we use to locate vertices. C locates our foci, and B locates the points of the ellipse. And let me scroll up a little here. That lie on the minor axis. So if you can see here, A locates the vertices because the coordinates of the vertices are negative A0 and positive A0. The foci are negative C0 and positive C0. So that's why we say C locate the foci. And then B is given by subtracting A squared minus C squared. We're essentially using the Pythagorean theorem more or less. But you can see the points where the ellipse crosses the y-axis essentially, which is our minor axis this time. That tells us our B. And we'll get into how all that works when we start doing examples. So just so we know, y is our minor axis and x is our major axis here. Okay, the other type of ellipse we have is where the major axis is the y-axis and the minor axis is the x-axis. So just to reiterate, the major axis is the y-axis on this one. The equation is almost the same, except the a squared and the b squared switch places. So a is still bigger than b, and they're both still positive, and we still find b squared by doing a squared minus c squared. But this time, the points are sort of changed. A still locates the vertices though. C still locates the foci. And B is still the location, helps us locate the points of the ellipse that lie on the minor axis. So to color coordinate here, here's our A's. Our C's still locate our foci. And our B's still locate the points on the minor axis. So right here and right here. All right, in the next video, we will start doing some examples of these.